Math students, it's Miss Eisenminger here, and I'm actually doing my first flip video. So bear with me, and hopefully we can learn about 2.4 proportional relationships and equations today. So basically the lesson starts with a key concept, and it says you have used tables and graphs to represent proportional relationships. An equation can also describe a proportional relationship between two variables. Recall that when there is a proportional relationship between x and y is a constant multiple of x. This constant multiple is the constant of proportionality. What I'm wanting you to get from all those fancy words is that in an equation, the m is your constant of proportionality. And think about it this way. The m will always be next to the x. So your constant of proportionality will be next to your x. So let's start with part 1 of our lesson and see what we are asked to do today with that information. Says your friend uses the equation y equals 8.5x to calculate the total cost y in dollars for x movies. What is the constant of proportionality? Well, the constant of proportionality in this is the 8.5 because it is next to the x. So if we answer B, what does the constant of proportionality represent in this situation? It would be the cost of one movie ticket. And in this case, that's $8.50. How much will 13 movie tickets cost? Well, we need to take 8.5 and multiply it by 13. And you will see that 13 movie tickets will cost $110.50. So now let's look at your got it. And see what we're asked to do on this. All right, so you're got it. It says the equation P equals 4S represents the perimeter P of a square with a side length S. What is the constant of proportionality? Well, you would answer it as 4 because that's next to the S, or think about it as your X before. So your constant of proportionality is 4. What is the perimeter of a square with a side length of 1.6? So to answer that, we just need to take 4 times 1.6. Let's do that. 4 times 1.6. The perimeter would be 6.4 meters. That is how you would answer that question. 6.4 meters. Before there on that calculator, I hit an extra button, so just ignore that part. Your answer is 6.4. Let's move to part 2. All right, for part 2, a certain vegetable dip contains 60 calories per serving. What equation represents the number of calories y in x servings of the dip? Well, 60 calories per serving. So I need an equation with 60 in it. And this thing's being squirrely. I'm just going to put that one down there for now. I'm going to put that one there for now, but those are not right. I'm going to slide this y equals 60x over, and then I'm going to read these two and see what we're doing. Let's go to the next one. At a telethon, a volunteer can take 60 calls in 5 hours. Guys, that's not a unit rate. If you go back up to this one, 60 calories per serving. That's 60 calories for one serving. So our equations always have to have a unit rate in them. Like this one was good to go. This one is not good to go. 60 calories in 5 hours. So we need to figure out how many calories in 1 hour. 60 calories in 1 hour or in 5 hours would be the same thing as taking 60 divided by 5. That would be 12 calories per hour. So I'm going to put that one there. And then if we go to this one, a machine can make 60 keys in 12 minutes. Again, that's not a unit rate. So 60 divided by 12 gives us a unit rate of 5. So that would be the answer to that. All right, for your next part of part 2, you got it. You paid $2.50 for 5 apples. Again, that's not a unit rate. Let's figure out what 1 apple cost. So $2.50 divided by 5, one apple would be 50 cents. Okay, now we have our unit rate. So now we can write the equation. Write an equation to represent the total cost y of buying x apples. So my answer would be, let me pull my pen up, y equals 50 cents is 0.5 x. That would be my equation. I found my unit rate. Let's start with part 3. All right. 3 starts off with this long introduction talking about traveling to another country. It says, when you travel to another country, you often need to exchange US dollars for the local currency. When you exchange money, you receive the equivalent amount in local currency based on the exchange rate. An exchange rate is an example of a constant of proportionality. Recently, the exchange rate for US dollars to Indian rupees was $1 is 45 rupees. The constant of proportionality is 45 rupees per dollar. Okay, for part 3, example 1, it says you're going on a trip to Spain. When you ask for the exchange rate, your bank shows you this table. Write an exchange you can use to find how many euros you will receive in exchange for X US dollars. Well, guys, let's see. So we need to remember that X is represented by the US and Y is euros. So first thing I need to do is find my constant of proportionality. My unit rate is another way to think about that. So if I just do the 100, I like 100 because it's easy, and I say, okay, 75, get my pen selected, 75 over 100 would be 0.75. And I'm, again, just looking at this one here because of this nice 100. So 0.75 is our constant of proportionality. So if I was going to write this equation to find how many euros you will receive for X US dollars, that would be Y equals 0.75X. And then mentally, I would think about it like this. Okay, check myself. If I have 120 US dollars, and US is the X, 0.75 times 120 would give you 90 euros. So we did it right. Let's move to the next problem. All right, this problem just wants you to realize that sometimes you're going to have to reverse things. It says you have returned from your trip with euros left over. Use the table to write an equation you can use to find how many US dollars Y you will receive in exchange for X euros. Okay, so we're flipping things around. We're going the other way. Before we put the 75 over the 100. Now we're going to put the 100, my pen, 100 over the 75, and you will see that you would get something like 1.3. So now your equation would be y equals 1.33x. And you're finished. This would let you know that if you had, let's say, 75 euros, 1.33 times 75 would give you 100 US dollars. Okay, the last part of our lesson for today deals with proportions, and this is something that you will use a lot in math. It says in a local soccer league, the ratio of goalies to the number of players on a team is 2 to 30. So what I'm going to do is put goalies over players, and there's 2 goalies for 30 players. Now, if the league has 915 players, so that is a P, that 915 is going to go down here. How many goalies are there? Okay, so we've done a lot of talking about, okay, is there something nice that I can multiply by 30 to get me 915? And if there were, I could multiply that by 2 and that would be done. But this one's a little bit messier to think about. So what I would do is I would just use some cross multiplying. And this always works. It's a beautiful thing. So I take, you're going to multiply this way. 30 times x, 30 times x is 30x equals, and then 2 times 915, and I don't know that one off the top of my head, so there's no harm in using a calculator. So 915 times 2 is 1,830. And then let's solve for our x, our unknown. Divide by 30, divide by 30. So 1,830 divided by 30 will give us our final answer, 1,830. divided by 30. Our answer is 61. So your answer to this math problem would be, there would be 61 goalies. Two more, got it. And then let's be finished for the day. So here we go. The ratio of defensive players to the total number of players in a different soccer league is 9 to 30. So I'm going to put, let me get my pen, defensive players to total players. And it's 9 over 30. If the league has 890 players, so that's total, how many defensive players are there? There's my X. Again, I don't know 30 times what is 890. I could probably figure that out, but let's just use our new cross multiplying because I have a feeling you guys will learn to love this. So 30 times X, right here, we're going this way, is 30X. Now, I need to know what 890 times 9 is. So 890 times 9 is 8,010. Now, divide by 30, divide by 30. So 8,010 divided by 30 is 267. My answer to this math problem would be 267 defensive players, and that's it.